This video is about translating mathematical phrases to rational algebraic expressions for 8th graders. 8th graders, welcome to your virtual classroom. The following are some simple reminders to make your learning as smooth and easy as possible. Use the module with care. Do not put unnecessary marks on any part of the module. Therefore, you need a separate sheet of paper and a pen in answering the exercises. Don't forget to answer "What I know" before moving on to the other activities included in this module. What I know is the pre-test in each module that checks what you already know about the lesson to take. Read the instructions carefully before doing each task. Observe honesty and integrity in doing the tasks and checking your answers. Finish the task at hand before proceeding to the next, one at a time only. For your convenience, please pause and replay this video to maximize your learning. Now, let's begin. What you need to know. Determine the symbols, variables, and operations in translating verbal phrases to algebraic expressions. Translate mathematical phrases to rational algebraic expressions. What's in? Now, let's start this lesson by recalling your knowledge about polynomials. The word polynomial can be dissected into two words, poly and nomial. Poly comes from the Greek word polus, which means many. Nomial, on the other hand, comes from the Latin word nomen, which means name or term. Combining these two words, polynomial simply means many terms. For example, 4a is a monomial. 5x squared plus 6 is a binomial. 5y cubed minus 20y squared plus 60 is a trinomial. 21b to the fourth plus 7b cubed minus 35b squared minus 70 is a multinomial. In other definition, polynomial is an expression of more than two algebraic terms, especially the sum of several terms that contain different powers of the same variable or variables. In this example, we have 1, 2, 3, 4. We have the sum of 4 terms with different powers of the same variable, which is b. This is the fourth power, our first term. The second term has the third power. Our third term has the second power. And our last term has the power of 0. Now, what's new? Let's have activity 1, translate me. Translate each verbal phrase into a mathematical expression. Choose your answer from the different shapes below. Write your answer on a separate sheet of paper. Now, before we answer, let us refresh on the following translations. Sum, which means addition, will have the addition sign. Decreased by or less than, which means subtraction, will have the subtraction sign. Product or times, which means multiplication, of course will have the multiplication sign, or you could simply put the two variables, a number and a variable, together like this. Look at my mouse. And lastly, dividing or quotient which obviously means division. You can use an obolus or a vinculum, this bar right here. Now, let's go back. Number 1, the sum of a number and 3. What shape could that be? You are right. It is the rectangle or the square, x plus 3. Number 2, the quotient of m less than w and k. And that shape is perfect. It's the inverted triangle, m minus w over k. Let's have number 3, half of a number decreased by 1/3 of another number. And that should be, good job, it's the hexagon, 1/2 x minus 1/3 y. Number 4, the quotient obtained by dividing 4x minus 1 by 3. That shape should be perfect. It's the decagon, 4x minus 1 over 3. And lastly, the square of the product of 11 times a number. And that is perfect. It's the oval. It's the quantity of 11n raised to the power of 2. Very good. Did you get 5 over 5? Wow, genius. Now, what did you consider in translating the phrases to a mathematical expression? Are the mathematical phrases polynomial? Why? How do you describe a polynomial? Now, for the answers of these questions, submit them to your teacher. In Activity 1, Translate Me, you were able to deal with translating verbal phrases to mathematical expressions, which are mostly polynomials. The previous activity can help you in dealing with word problems as you move on to the next modules. But how did you do it? How did you choose the variables and operations in translating to a mathematical expression? Now, in this lesson, you will deepen your understanding and knowledge on mathematical expressions and encounter some expressions that are not polynomials. Translating mathematical phrases to rational algebraic expressions. What is it? In translating verbal phrases to mathematical expressions, we need to use numbers. The common symbols of operations such as addition, subtraction, multiplication, and division. The symbols for groupings like parentheses, brackets, and braces. And of course, don't forget the variables, which means any letter of the English alphabet which is used to represent a number or several numbers. If a variable stands only for one specific value, we call it a constant. Very good. Now, the operation of multiplication can be represented by the symbol, the multiplication symbol, or by parentheses, or by using a dot, which is written halfway up the factors. For example, the product of 3 and a number b can be written using parentheses. Parentheses, we have 3 inside. In parentheses, we have b inside. Or a dot, which is in the middle of your factors and which is halfway up the factors. Very good. Or simply put them side by side. But never put two numbers side by side. it will not mean multiplication. A number and a variable can be. Two variables can also be. Now, what about division? Division can be represented by the obolus and the vinculum. The quotient of a number x and 7 can be written using an obolus, x divided by 7, or the vinculum, x over 7. In addition to the words add for addition, subtract for subtraction, multiply for multiplication, and divide for division, there are other terms that also correspond to these mathematical operations. Now, you can read with me. For addition, we have increased by, plus, sum, total, more. For subtraction, we have decreased by, minus, difference, reduced by, less than. For multiplication, we have product, times, twice, of. And lastly, for division, we have quotient, shared, split between, divided by, and ratio of. Now let us have some examples. We begin with addition. And, for example, add 6 to a number A, that's A plus 6. 8 increased by a number B, that's 8 plus B. A number C plus 9, that's C plus 9. Sum of the numbers D and E, that's D plus E. Total of the number G and 9, that's G plus 9. 6 more than twice a number H, that's 2H plus 6. Let's move on to subtraction. Subtract 6 from a number J, that's J minus 6. 8 decreased by a number K, that's 8 minus K. A number L minus 7, that would be L minus 7. Difference of the numbers M and 2, that's M minus 2. 6 reduced by a number N, that's 6 minus N. 5 less than half a number P, that is 1/2 P minus 5. Again, you can pause and replay this video to maximize your learning. Now let us have multiplication. Multiply 4 by a number Q, that's 4 times Q. Product of a number R and 7, that's R times 7. 5 times a number S, that's 5S. Twice a number T, 2T. 1/3 of a number U, that's 1/3 U. Now let's have division. Divide 4 and a number V, that's 4 divided by V. Quotient of 9 and a number W, that's 9 over W. A number X shared equally by 3, that's X divided by 3. Split 90 candies between Y number of children, that's 90 over Y. 40 divided by a number Z, that's 40 divided by Z. Ratio of 100 and a number A, that's 100 over A. Sounds good? That's perfect. Now let us have some verbal phrases turned into algebraic expressions. Example number 1. The difference of twice a number and 3 divided by the product of 4 and another number. Now our solution, if x is a number and y is another number, then twice a number is equal to 2x. Product of 4 and another number is equal to 4y. Therefore, the difference of twice a number and 3 divided by the products of 4 and another number. Sounds good? Again, you can pause and replay this video as needed. Example number 2. A number over the product of 3 and another number. Okay, if m is a number and n is another number, then the first number is m, product of 3 and another number is 3n. And so, a number over the product of 3 and another number. That's m over 3n. Very good. Now let's get a hang of it. Last example. The ratio of x plus 5 and the product of 4 and x. Ratio of means fraction and means quotient. Product of 4 and x is equal to 4x. Therefore, the ratio or the quotient of x plus 5 and the product of 4 and x. Okay, now you can pause and replay this part of the video as needed. Now, before we move on to what's more, let us take one last look at the solution. In order to change or to translate verbal phrases to algebraic expressions, we have to consider the following. Number 1, we identify the unknown quantities. In this example, we have x and y because there are two unknown quantities. And then, we also identify the operations that are going to be used to translate verbal phrases to algebraic expressions. Again, first, we identify that's good. We identify the unknown quantities and represent them with variables. Perfect. And of course, identify the operations that will help us translate verbal phrases to algebraic expressions. Now, for the last example, the quantities are given. We have x plus 5 and 4 and x. All we need to do is look for the operations, which are quotient or division and product or multiplication. Okay, now I think you are ready for what's more. Activity 2, translating time. Translate the following verbal phrases to rational algebraic expressions. Write your answers on a separate sheet of paper. The ratio of 12x by 5y. The product of 3x and 5xy. The fraction whose denominator is 15 and the numerator is a number more than the denominator. The quotient of 7y minus 2 by y plus 2. The product of y and a number over the sum of x and 1. The average speed in 25 m plus k traveled in 5 plus t hours. Now again, please submit your work on time. Can you give me a thumbs up? Thank you very much. Now here is what you need to remember. Symbols of operations like addition, subtraction, multiplication, and division. Grouping symbols like parentheses, braces, and brackets. And variables like A, B, C are used in translating verbal phrases to algebraic expressions. Variables are letters in the English alphabet used to represent a number. For example, A is equal to 1, B is equal to 2, C is equal to -3. And lastly, multiplication can be written by the symbol multiplication sign, parenthesis, or a dot, which is written halfway up the factors. Benjamin Franklin said, "Tell me and I forget. Teach me and I may remember. Involve me and I will learn." This has been your teacher, Ms. Mary Kate. Get involved and keep on learning.